Designing of structure. Knowledge of soil chemical, physical properties, and geotechnical parameter of soil. This can be achieved by investigating of the soil surface and subsurface strata. Several selected boreholes used for collecting samples that represent different soil condition for structure. Sampling method of soil controlled by soil condition. ASTM D1587 method is recommended for soft soil where a thin-walled tube used for sampling. For gravel, large soil cemented particle, and hard soil ASTM D158699 shall be used for sampling. In ASTM 158699 soil samples obtained using split barrel sampler. All acquired samples shall be placed inside plastic bags and sealed properly to avoid moisture loss. Each sample shall be labeled and identified. The following tests are conducted on soil. Standard penetration test, SPT, used to assess the relative density and consistency of soil. Test apparatus including split barrel sampler, drill rod, and drive weight assembly. The SPT value defined by the number of blows required split barrel sampler to penetrate 300 mm after initial seeding of 150 mm under compaction energy generated by hammer weighting 63.5 kg falling from 0.76 meter height. The test shall be conducted for various depths. Particle size analysis can be determined using ASTM D422-63. For particle sizes larger than 75 micromillimeters or not passing sieve number 200, it shall be tested using a sieve analysis. On the other hand, for particle passing sieve number 200, it shall be tested using the sedimentation process. Since the particle's sedimentation velocity depends on particle size, hydrometer used to measure particle size. Unconfined compression test. This test used to determine unconfined compression strength for cohesive soil. It shall be carried according to ASTM D2166. In this test, the specimen should have a cylindrical shape with ends perpendicular to the longitudinal axis of the sample. The specimen shall be loaded with axial force, causing an axial strain of 0.5 to 2%. Several measurements shall be recorded for load, deformation, and time. The rate of strain should be in a way that the specimen will fail in less than 15 minutes. The loading should carry on until the load value decreased with increasing strain or if the strain is 15%. The unconfined compressive strength is the compressive stress at failure. The shear strength is half of the unconfined compressive strength. Atterberg limits. Atterberg limits introduced by Albert Atterberg. Initially, it is 6 limits, but currently, Atterberg limits referring to plastic limit, liquid limit, and shrinkage limit. Plastic limit defined as the content of water at the boundary between plastic state and semi-solid state. The plastic limit can be determined using ASTM D4318. The plastic limit determined by rolling a soil sample into a thread of 3.2 mm diameter. The water content will be reduced until the soil thread crumbles and can't be rolled. At this point water content is the plastic limit. Liquid limit determined using this device. The soil sample spread inside the device cup and using a groove tool the sample split into 2 parts. Then the sample allowed to flow under the influence of shocks generated by repeatedly dropping the cup. Once the groove closed at the bottom, the number of blows and water content will be recorded. Several trials shall be done for different water content. The liquid limit is the average of liquid limit for each trial. Water content. Water content can be determined using ASTM D2216. A sample dried at the oven for 18 to 24 hours at 105 Celsius degree. The difference between sample mass before and after drying is the water mass. Water content is the ratio of water mass to solid particles after drying. Point load strength index of rock. This test used to determine the point load strength index for rock. The testing specimen subjected to increasing point load using coaxial truncate conical pitons until it fails. Specimen deemed failed when splitting a yard. California bearing ratio. CBR used to evaluate the mechanical strength of the soil. Sample of soil prepared into a cylindrical mold. Then a cylindrical plunger of 50 mm diameter forced to penetrate the sample at a controlled rate. The CBR determined by dividing the unit load on the piston that causes penetration of 2.5 mm and 5 mm to unit load required to penetrate standard material of well-graded crushed stone. Chemical and groundwater chemical analysis. Chemical analysis shall be conducted to determine the chemical composition of soil and groundwater. The chemical composition can affect the selection of concrete and reinforcement type. For example, if the sulfate concentration is high, the selected concrete for the foundation shall be sulfate resistant. Sulfate can adversely affect the concrete by causing expansion of concrete, and this will lead to cracking and spalling of concrete. Soil investigation report shall contain the results of tests mentioned above, soil strata profile, a recommendation for bearing capacity for shallow and deep foundation, predicated settlement for foundation, and the level of underground water.